You are welcome to today's class. Now, today's class will be teaching half-life of a radioactive element.
At the end of this lesson or during this lesson, you should be able to state the equation used to calculate half-life of a substance. Okay, then the second outcome is that you should be able to calculate the half-life of a substance provided you are given the initial amount or you are given the count rate, time elapsed, and the remaining amount or activity. You should also be able to calculate decayed amount or activity provided half-life, time elapsed, and the initial amount is given. So these are our outcomes, expected outcomes for this lesson. So let us quickly go into an example. Example 1. So in this example, we are told a certain radioactive substance has an initial mass of 40 milligrams. After a period of 40 minutes, only 2.5 milligrams of the sample remains. The first question A is calculate the half-life of the substance. Then the second question B is how much of the sample decayed during this period. So you can see that in this question we have this outcome that is looking at calculating the half-life of a substance provided you are given the initial amount, the count rate, the time elapsed, and the remaining amount or activity. That's where the first question is coming from, where you are supposed to calculate half-life. The second part of this question, how much of the sample decayed, is covering this objective that is talking about calculating the decayed amount or activity provided you are given the half-life of a sample, the time elapsed, and the initial amount. Okay, so quickly let us look at the solutions to this question. So the first thing for us to be able to answer these two questions is to find out how many half-lives are there in these 40 minutes of this sample. We do not know the half-life, but we know the total time that elapsed, that it is 40 minutes. So we can actually calculate or determine the number of half-lives in this total time that elapsed. So there are several ways in which we can actually determine the number of half-lives. Determining the number of half-lives is the initial point. It's the beginning point where we can now calculate the half-life, and if we have the number of half-lives, we can now know how much of the sample decayed during this period. So to begin with, we are going to calculate the number of half-lives for the sample. Okay, so the solution. So the equation we are going to use to calculate half-life of a sample, to calculate the number of half-lives of a sample, is this. Now this equation, in this equation, capital letter N stands for the amount that is remaining. It could be activity or it could be the amount. Like in this case, this question is not dealing with activity, it is dealing with the amounts. So N is the amount that is remaining after that time has elapsed. Then N0 or N0 is the amount we had when we just started or before that 40 minutes elapsed, actually at the beginning point of the 40 minutes. So when time is 0, what amount did we have? So this is the initial amount, and then we have half there and letter N as the power or index. Now letter N is standing for the number of half-lives. So we can proceed as follows. The amount remaining when we go to the question is 2.5, because we are told only 2.5 milligrams of the sample remains. So that's the amount remaining. 2.5 milligrams is equal to the initial amount. We are told that the sample had an initial amount of 40 milligrams. So that's our initial mass or amount, that's 40 milligrams. Then this is a constant half and power N, and that's the N we are looking for, the number of half-lives. So from this point we can divide both sides of this equation, this and this, by 40, so that we get rid of this 40 here and just remain with half to the power N. So this 2.5 is divided by 40, and this is equal to, here we just remain with half to the power N because 40 has divided itself. So when we reduce this, we get 2.5 divided by 40 is 1 over 16, which is equal to 1 over 2 to the power n. So at this level, we can use the idea of indices if we want, or we can go the logarithm way. So using the idea of indices, we express, for that. So we express 1 over 16 as 16 to the power negative 1. I think this is mathematics from grade 10. So this is equal to, again, this half is expressed as 2 to the power negative n because it's no longer a fraction. After that, we can now treat this 16, express it as a number with a base of 2. So if 16 is going to have a base of 2, then it is going to be 2 to the power 4. Now that power 4 will be multiplied by the negative 1 that is already there, and it gives us 2 to the power negative 4 is equal to 2 to the power negative 1. We do the same here, express half as a number with a base of 2, so it becomes 2 to the power negative n. So at this level, we can conclude to say n is equal to 4. Since these 2 and these 2 will divide, or in short, they are the same. So we are saying negative n is equal to negative 4. And we can drop the negatives or simply divide throughout by negative 1. So therefore, the number of half-lives is equal to 4. So this is one of the ways in which we can determine the number of half-lives. Or better still, if you have an idea of logarithms, you get the formula just like we started. You put the amounts. The amount remaining is 2.5 milligrams, and the initial amount, the amount we started with, is 40 milligrams, and this is equal to 1 over 2 to the power n. Now at this point, you divide both sides by 40. This time we are not going to express our answer in terms of fractions, but we are going to use decimals. So when 2.5 is divided by 40, we are going to get 0.0625. And 40 divided by 40 here, we will remain with the 1. And it simply means this would disappear from this side. And then here we are going to say 1 divided by 2, and we get a 0.5 to the power n. In short, we will express 1 over 2 as a decimal, which is 0.5 to the power n. From this point, we can introduce logarithms on both sides. So here we have log, and this is the log to the base 10, so we don't show 10. If you remember, if you have an idea of logarithms, or we simply say log. Excuse me. So this is log 0.0625 is equal to log 0.5 to the power n. So we proceed from here. We want to bring this n down. So again, I'm depending on ideas of logarithms. If you have an idea of how logarithms operate, if you have n here, when you bring it, you can actually bring it in front of log here. Okay, so if n disappears there from here, then it will find itself in front here of the log. So instead of writing log 0.5 to the power n, we will write as n log 0.5. That's how logarithms operate. So we have log 0.0625, which we had here after dividing 2.5 by 40, and then introduce log. So log 0.625, and then we bring the n down, it becomes n log 0.5. At this level, since we are looking for n, we divide both sides by log 0.5. So it means n is going to be log 0.0625, log 0.0625 divided by log 0.5. And when you carry out this computation using a calculator, your value of log 0.0625 divided by log 0.5 is going to be 4. So n is 4, just like the way we found the n here. So it will be the same value 4, or you use this formula, it will still give you the same value of n, which is equal to 4. Or still, you can find the value of n by reducing the given mass of a sample in halves. This is actually a very simple way of finding the number of half-lives. You simply say, since we know the initial amount is 40 milligrams, if this amount decays by half, since we know that half-life is time taken for a sample to decay by half, So when one half-life, we are looking for the number of half-lives in the total period that elapsed, which is 40 minutes. So if one half-life elapses, then the 40 milligrams will remain 20 milligrams. Then after another half-life, the second half-life, we are going to remain with 10 milligrams. Then after the third half-life, we will remain with 5 milligrams. After the fourth half-life, we are going to have 2.5. Now, we will not proceed from 2.5 to get 1.25 because actually we have arrived at the amount that was mentioned in the question, that this is what remained. So we end here and count the number of half-lives. So 1, 2, 3, 4. So we have the number of half-lives. So it depends on which method. If you are using this method, please, you need to indicate clearly that this is what you are doing, just like the way I have expressed it here. All right? So after that, we have found the number of half-lives. Now we can use a very simple formula to find the half-life. So half-life of a sample is equal to total time elapsed over number of half-lives. So in this particular case, the half-life of a sample is the total time that elapsed, 40 minutes, divided by the number of half-lives, which in this particular case is so 40 minutes is the total time that elapsed divided by the number of half-lives, which is 4, and we get 10 minutes. Okay, now we have found the half-life of a sample, that it is 10 minutes. So we can go back to our question to see what the other question was talking about. That's B. Okay, so part B of our question was asking us to calculate how much of the sample decayed during this period. It's not talking about how much actually remained, but it is talking about how much decayed. Okay, so what we'll do is, to find the amount that decayed, you simply subtract from the initial amount you had, you subtract what you have remained with, then the difference is actually what decayed. So we can look at the solution here. In fact, from here it's very simple. You can see we had 40 milligrams, then the final mass is 2.5 milligrams. So what has decayed is 40 milligrams minus 2.5, which is expressed here as 40 milligrams minus 2.5 milligrams, which is 37.5 milligrams, as the amount that decayed. If the question was saying find the amount that remained, then it is just that 2.5, but the question can't be phrased like that because in this particular case we were already given the amount that remained. Okay, so let's look at an example from a past paper. Like you saw from the beginning, our lesson includes solutions from past papers. So we want to look at how we can actually solve questions from past papers. So let's look at this simple question from a past paper, from the multiple choice part. So this one was actually question 19, and it reads, a radioactive substance has a mass of 600 grams and a half-life of 12 years. How much of the substance decays after 36 years? Okay, so how do we solve that one? So we see, using this formula, by now I believe you understand that what the formula stands for. So N means the remaining amount, NO or N naught means the initial amount, and N small letter is the number of half-lives. So even before we proceed, we can actually find the number of half-lives in this particular question. We are told the total time that elapsed is 36 years. And we are told that the half-life of the sample is 12 years. If you go back to the question, that's what it actually says. It says the half-life of a sample is 12 years, and the substance, how much of this substance decays after 36 years. So this is the total time elapsed, and this is the half-life of the sample. So you go back to, you find N, make N the subject of the formula. From this equation we used here, half-life is equal to total time elapsed over N. Now make N the subject of the formula. It gives us N is equal to total time elapsed over half-life. So 36 years over 12 years gives us 3. So 3 is the number of half-lives. So we can pick this 3 and then put it in this equation where the initial amount is what we are looking, the final amount that will remain is what we are looking for. This question is not asking how much decayed, it is asking what remained. So, sorry. This question is also asking us what decayed. So we have initial amount, amount that remained is equal to initial amount, which is 600 multiplied by half to the power n, but the value of n is 3. So when we proceed using basic mathematics, we find that n is equal to 75 grams. So after finding that n is 75 grams, this is actually the amount that remained, but we want what decayed. So since the question is asking for what decayed, so you proceed. So this is the explanation I made here to say 75 grams of the radioactive substance remained. To find the amount that decayed, we subtract what remained from the initial amount. So 600 grams was our initial amount. We subtract 75 grams and we get 525 grams as the amount that decayed. So in this particular question, the correct option was D, 525 grams. All right? So from there, this is an exercise for you actually to do, and it reads, before that, there's this question in our next, there's this statement here. In our next lesson, we will be looking at graphs of radioactive decay. So graphs of radioactive decay is actually another way of calculating, determining how much has decayed, at what rate is it decaying, and also how much is remaining, apart from the equation that we have used. So for your own activity exercise, you can go through this question. It is also from a past paper question. So it reads, a radioactive element X with the neutron number 223 and the proton number 98 emits one beta particle followed by two beta particles. What is a beta particle? You get 1 mark if you explain that. Write the nucleon number and the proton number of the remaining nuclide after the two emissions. You get 2 marks. You rely on the equations we did on the radioactive decay to be able to answer these questions. C, a 400 grams radioactive substance has half-life for 4 years. On a graph paper. Okay, for this part where we'll be dealing with a graph paper, we leave it for now. After we do our next lesson on graphs of radioactivity, of radioactive decay, then I'll repeat this question, this part, so that you'll be able to answer it. Otherwise, thank you so much for watching up to the end. I wish you all the best as you prepare for your exams if you are writing, or if you are not writing and you know someone who is writing, please, you should always remember that sharing is caring. Share this video. Let someone who is writing their O-level science exam this year pass or be helped to pass their exams. Thank you so much. Remember to like our page NTC and to share our Facebook page NTC. See you in the next lesson.